session. The session is being recorded. All right, so today we're going to take on somewhat a topic that is one step ahead of what we have been doing, except we're going to simplify it because we don't have the mathematical skills to become analytical about it. At least we just need to build the function first before we get analytical. Certainly not today. We're going to talk about polynomial functions. Okay? We're going to talk about polynomial functions. I see the way, due to some technological distortion, it's not properly presented in your folders. So I'm going to repost that part of the folder that does not really show a polynomial function for what it is. What we're going to do is I'm going to show you what a polynomial function is, and then we are going to simplify the solution, the solutions to the polynomial functions, and not really simplify, but we're actually going to evaluate a polynomial function, and then we're going to graph it. And so we are going to use graphs to be able to apply polynomial functions to anything. It's mostly graphs. Okay, so I'm going to pull up an example of a polynomial function. So I will share my screen. All right. Okay, so that is what a polynomial function looks like. Okay, now a polynomial function is simply a function with several powers of a variable. Okay, it is stated like in a straight line, and you have, say, the variable is x, as in this case, then f of x will be a plus a coefficient like a1 to the power x1, a2 to the power x2, and a3 to the power x3, and a4 to the power x4, and all the way to the power n. Now, there's nothing particularly mysterious about this. The A1 and A2 and A3 and what have you simply represent coefficients of x, and the numbers that you see at the top, like x to the power 2 and x to the power 3, x to the power 4, are simply the powers of the functions. So I'm going to change that. Okay, and a5 to the power 5, and so it needs to be changed. Okay, and what you simply have here, when you see a, it simply means a coefficient. Okay, and then you see here we have a, and the number there is a subscript. And a1 simply means the coefficient for the first power, and a2 simply means the coefficient for the second power. And so I have an example here for you. This is a degree. This is a polynomial function of degree 3. So, for example, what is the degree of a polynomial function? the degree is the power, okay? For example, a polynomial function of degree 3 has x's up to the power 3, and it has 3 parts, okay? It has 3 parts with x. So in this function, f of x is equal to 4, which is a constant, which is where the function begins on the y-axis, and then 2x. So 2x is the first variable here, which the first component. And so you can see x is raised to the power 1. X raised to the power 1 is x. And then the second power is 5x to the power 2, which is the second component. And so you raise it to the power 2. And then the third component is raised to the power 3. If it had a fourth component, then x will be raised to the power 4. Okay? So this 7 here, this 5 there, and this 2 here represents A1, A2, and A3, okay, that you see up here. Okay? That's what they simply represent the coefficients of x as you go from power 1 to power 2 to power 3. So that's just a conceptual understanding of what a polynomial function is. Okay. Now, I mean, today's lecture is going to be very short. So what I'm going to do is I'm going to evaluate this function. Okay. Let us say that t is, say, 3. Let us say that t is 3. So let t equals 3. Okay. All right. Let t be equal to 3. 3 could be time. Okay. So how do we evaluate this function? How do we evaluate the function? R of t. So R of t. Okay. It can be f of t. All right. So R simply refers to revenue. So when we say, what is the revenue over time? Okay. What is the revenue in the 4th period? Let t be time. Okay. And so t goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, let t be 4. And so we're going to evaluate this function, and I'm going to put it on an Excel file. We're going to evaluate this function, and it will be minus, okay, be minus 0.037 times 4 to the power 4, because t is 4, oh, sorry, 0.037 times 3 to the power 4. So that is, we raise 3 to the power 4. So I'm going to raise it to the power 4. Okay, so all right. So 3 to the power 4 is what? Okay. And plus 1.414 times 3 to the power 3. Okay, I'm going to take this. All right, so you can see plus, okay, this is a minus 19.777 times 3 to the power 2 plus 118.696 times 3. Since it's to the power 1, we don't have to do anything. Minus 205.332. All right. So now, so what is R of t? That is, what is the revenue at any time t? Any time t. Okay. 3 to the power 4 is what? Does anybody know? Three. Yeah, somebody give me the answer, okay?
81.
81. 81, you are correct. 81. So we have then minus 0.037 times 81. All right. Plus 3 to the power 3 is 27. 1.14 times 27. Minus 19.777. 3 to the power 2 is 9. Times 9. Plus 118.696 times 3 minus 205.332. 205.332. All right. So you have that. All right. All right. So then R of t will be equal to, what is 0.037 times 81? 1037 times 81 is 2.997 minus 2.997 plus 8.178 minus 77.993, 177.993 plus 118.696 times 3, 356.088, 356.088 minus 205.332. Okay, and so what is it then? Can somebody tell me, give me the answer? Okay, I'm listening. Somebody put that together and give me an answer. Hello?
I'm doing the calculations. I'm going.
All right.
It's not coming out.
So what? What happened? People are dropping out. I admit them and they drop out again. Okay. I get 9.944. Is that correct?
I don't know.
Okay. I get 9.944. All right. So now 9.944. Now, what we're going to do is we're going to put it in an Excel file. Okay. And then we'll graph it. So let us see if we can graph this. See how we graph it. We have the function. Okay. And we graph it for, first of all, we have to do a calculation for each power of t. Okay. Okay, we'll copy that. We stop the share. All right, so we put up an Excel file. Okay, so I'm going to so here is the Excel file. We're going to put this function up there. And here is the file. So here we have arrow of T. Okay, there we have T. We'll have T. We can start from 0. One, two. We're not going to go that far. Okay. And so now based on the work we did, let's pull up that work. The way we
So how far do we need to go when we are gonna graph it on Excel?
probably up to maybe 15 or 20.
15 or 20, okay.
Yes. Okay. So now we have here equals bracket minus 0.037 times and values are in I, so we take from I4, to the power 4 plus the double bracket plus 1.414 stir I4 to the power 3 double bracket minus 19.777 star bracket I4 to the power 3 double bracket plus bracket 118.696 star bracket I4 bracket minus 205.332. All right, so you can see here that we have minus 205, and we just drag it down. I'm gonna just go up to 45. Okay. Okay, something is missing. Okay, we cannot have everything's negative. I4 okay, to the power 4. Okay, here they're missing something, and this is how you check your work. 118. This is star 3. .77. This is to the power 2. All right. All right. As you can see, now we have positive numbers, and then we begin to have negative numbers. So now to plot this, you have to make it possible for the processor to recognize the T functions as not regular numbers. Okay, and so we can plot a chart. We can plot a chart and you insert going to move this. Insert a line chart. And you move the chart. Chart 1. And so this is what you see, okay? So you have a chart which shows the time. The times are up here, and the values are on the left. You can use the original thing if you prefer that. Use the original thing. And you don't have to go all the way. Insert a line chart. This is distorted, so it was better the other way around.
So we're supposed to have 2 charts per example?
No, you have only one.
Just one. Okay.
Just
This
one.
so this one that you're showing us now is it's just
No,
not working out.
I was just trying something else, and it's not working. Okay, so where the independent variable is on the left and the dependent variable is on the right. So you have to do it right, so that a lot of students get confused and they don't know where to place the dependent and independent variable. And you can see, in order to make this work, you see the times from 0 to 1. If you plot them together without putting the apostrophe on the left side of the numbers, you're going to get a distorted chart. Okay, it will give you 2 lines, which is something that you want to avoid. Let me see if I can highlight it so that you can see what I mean. Okay, I'll highlight it. So you can see the apostrophe to the left side is coming in. To the left side of the numbers. So that makes it possible for you to plot the chart. Okay, and so it's much better when you are done. You take the chart, you cut it, copy it. I'm going to stop share for a minute. You copy the chart. And what I usually do, I copy the chart and put it on a plain MS Word. Okay, and it's a much neater chart so that you can see the numbers here. And this is just one chart you need. You don't need 2 charts. No, just one. All right.
Okay.
Okay.
Mm-hmm.
All right. So that's the much we're going to do today. But I just wanted to show you how to follow the homework assignment. All right.
All right. Thank you so much. I appreciate your time.
All right. So does anybody else have any questions? Xenia, you just came back in. What happened?
I know. I kept getting dropped and I was on my way home and I just logged on my computer.
Okay. All right. No problem. I'm going to post this for everybody's benefit. If we need to move the time to 6:30, we'll move it to 6:30 so that everybody is able to come in. Okay, I'll consider that. Maybe next week I'll move it to 6:30 so that everybody can come in. So you don't be rushing from work. All right, so that's it. So I thank you all for coming.
Thank you.
Thank you.
Thank you very much. I
Appreciate your
guess
time
I'll
again.
watch the recording.
All
It's
right.
really helpful.
Okay, so we'll see you next time.